Look at this. This is what the sky above us would look like if Saturn replaced our moon. Strange, isn't it? Almost beautiful, but also a little terrifying. Those massive rings stretching across the horizon. But what would really happen to us, to Earth, if this were real? Spoiler, it wouldn't be peaceful. Saturn's size and gravity would, well, let's just say Earth would never be the same. Tonight we'll go step by step. We'll talk about Saturn, yes, and the disasters it could bring, slowly, in detail. And then we'll try replacing the moon with other planets from our solar system. What about them? So get comfortable. This is Sleep Blocks, your Roblox Sleepy Science channel. No rushing, no chaos. You don't have to like or subscribe right now. Just relax, fall asleep, and if you enjoy it, you'll know what to do. When you think about the moon, it might feel small, simple, almost ordinary. We see it so often that sometimes we forget how much it actually does for us. But the truth is, without the moon, Earth would be a completely different place, maybe even unlivable. First, there are the tides. Every time you stand near the ocean and watch the waves roll in and out, that rhythm is mostly the moon's doing. Its gravity pulls on Earth's oceans, creating those daily tides. Without the moon, the tides would shrink to almost nothing, only moved by the sun. That might sound peaceful at first, smaller waves, calmer seas, but it would completely change life near the coasts. Countless animals depend on tides: crabs, turtles, fish. Even humans long ago learned to fish and travel by following the tides. Second, the moon acts like a stabilizer for Earth. Imagine a spinning top. If it spins smoothly, it stays upright. But if it wobbles, it tips over. Earth is like that too. Our planet tilts on its axis about 23.5 degrees, and that tilt is what gives us seasons. The moon's gravity keeps that tilt steady. Without it, Earth could wobble wildly over thousands of years. Sometimes we'd tilt more, making summers scorchingly hot and winters brutally cold. Other times, we'd tilt less, and the seasons might almost disappear. Either way, it would be chaos for life trying to adapt. Third, the moon is our light in the darkness. Before street lamps, before electricity, people used it to travel, to plant, even to tell stories. Many cultures built calendars around the moon's cycles. Even now, when you look at the night sky, the moon is what makes it feel alive. Without it, nights would be darker, emptier. The stars would still be there, but the sky would lose its anchor. So when we talk about replacing the moon with Saturn or Mars or any other planet, it's not just swapping one object for another. It's removing something that has shaped our world, our climate, our culture, and even our feelings. That's why it matters so much. That's why the thought of changing it feels both exciting and dangerous. Let's begin with Mercury, the very first planet in our solar system, the one closest to the Sun. But closest in space doesn't really mean close the way we use it on Earth. The average distance between Earth and Mercury is about 48 million miles. 48 million. That's a number so big it's hard to even picture. So let's slow it down. Imagine an airplane flying at a steady speed about 600 miles per hour. If you got on that plane and headed straight for Mercury, no stops, no brakes, no fuel problems, it would take more than 9 years to get there. 9 years of sitting on a plane. Space is unbelievably, almost painfully, big. Now picture Mercury hanging in the night sky, right where the moon is. It wouldn't glow soft and white like our moon. Instead, it would look like a dark, cratered world, bigger than the moon, but still small compared to Earth. The moon is about 2,000 miles wide, while Mercury is a little over 3,000 miles wide. So in our sky, Mercury would appear almost twice as large as the moon we're used to. If you stood outside on a quiet night, you'd see its rough, battered surface more clearly, with giant craters and scars from billions of years of impacts. The colour would be different too. Instead of the pale silver glow of our moon, Mercury would shine a darker grey, almost like old metal. It wouldn't reflect light as gently. Some nights it might even look a little unsettling, like a scarred stone hanging above the world. For people on Earth, That sight alone would change the feeling of nighttime. The moon feels comforting, like a friend who's always there, calm and predictable. Mercury, though? It would feel harsher, less gentle, bigger, darker, more intimidating. Looking up at it every evening might even make nights feel less peaceful, more heavy, as if the sky itself carried a reminder of how violent the universe can be. But size and appearance are just the beginning, because once you add Mercury's gravity, its slow rotation, and the extremes of its environment, Earth would start to feel the difference in very real ways. And that's where things become less about beauty and more about survival. Mercury may look like just a bigger, darker moon, but the reality of this planet is much more extreme. In fact, it's one of the harshest places in the solar system. Here's something surprising. People often think of Mars as our closest neighbour, because Mars gets all the attention, the rovers, the missions, the dream of colonization. But if you look at the actual distances, Mercury often comes closer to Earth than Mars ever does. On average, Mercury is about 48 million miles away, which is around 77 million kilometers. Mars, by comparison, averages about 140 million miles, or 225 million kilometers. So in reality, Mercury is nearly 3 times closer. It doesn't get the same hype, but in terms of distance, Mercury wins. Now, what makes Mercury so extreme is its relationship with the Sun. Being the closest planet, it gets blasted with sunlight. On the side facing the Sun, the surface can reach about 800 degrees Fahrenheit. That's more than 400 degrees Celsius, hot enough to melt lead. But then, on the night side, without an atmosphere to hold in the heat, temperatures drop to almost minus 300 degrees Fahrenheit, or about minus 180 degrees Celsius. Imagine standing somewhere where one step forward feels like an oven, and one step back feels like a deep freezer. That's Mercury. Another thing, Mercury's days are incredibly long. One full day on Mercury, from one sunrise to the next, lasts about 59 Earth days, almost 2 months. So if Mercury replaced the moon, you wouldn't see a steady, calm face like our moon shows us. Instead, you'd watch its surface crawl across the sky, changing slowly, exposing new scars and craters over weeks at a time. It would make the night sky feel more alive, but also less predictable, less comforting. And what about its air? Mercury basically doesn't have any. There's no thick atmosphere like Earth's to breathe, no clouds to scatter sunlight, no layer to trap heat. Instead, it has only a thin exosphere. That's a scientific word for a kind of ghost atmosphere, made of just a few particles floating around. It doesn't protect Mercury, and it wouldn't protect us either. If Mercury were hanging above us replacing our moon, it would still look like a bare, naked rock, harsh, unfiltered, unshielded. So when you think about Mercury, remember, it's not just a rock in the sky, it's a planet of extremes, hotter than an oven, colder than the coldest place on Earth, spinning so slowly that nights stretch into months, and without a real atmosphere to soften anything. If it replaced the moon, Earth's nights would feel heavier, stranger, and maybe even more unsettling. If Mercury really replaced our moon, the biggest change wouldn't just be how the sky looks. It would be what happens down here on Earth. First, the tides. The moon's pull on our oceans is already powerful, shaping waves, currents, and even the way coastlines form. But Mercury is heavier and has stronger gravity than the moon. Compared to Earth, though, it's still small. That means Earth really could hold Mercury as a satellite. If it orbited as close as the moon does now, the tides would rise much higher. Whole stretches of beach would vanish underwater twice a day. In some places, the sea could reach far into towns that today feel safe. Over time, this would force cities near the coast to rebuild or even abandon whole districts. Imagine places like New York, London, or Tokyo constantly fighting against stronger floods. The cost of living near the ocean would change forever. Second, the rhythm of Earth itself. The moon stabilizes the tilt of our planet. Without it, Earth might wobble. With Mercury instead, the pull would be different, unsteady. Seasons could shift in strange ways. Winters might come later, summers might grow hotter, storms might appear in new places. Farmers who depend on predictable seasons would struggle. The food we grow could change, and so would the price of everything on our tables. And then there's the emotional side. Right now, when you look at the moon, you see something soft, familiar. It's part of human culture. A companion in the sky. Mercury would not feel that way. Its darker, rougher face, bigger and harsher than the moon, would hang over every night. For many people, it might create a sense of unease, even dread. Nights could feel less safe, more threatening. Over centuries, humanity might adapt. We always do. We'd build stronger walls against the ocean, adjust our calendars, tell new myths about the planet in the sky, but life would be harder. Survival near the water would be riskier. And the balance we take for granted now, calm seas, steady seasons, a friendly moon, would be gone. So, Mercury, as our moon, wouldn't end the world instantly, but it would make Earth less stable, less comfortable, and far less predictable. For a planet that has shaped itself around the gentle pull of the moon, replacing it with Mercury would be like swapping out a steady friend for a rougher, heavier stranger. The difference would be felt everywhere, in the oceans, in the climate, and even in our hearts. But with the bigger planets waiting ahead, like Venus or Mars, things wouldn't be so simple. We've looked at Mercury, the tiny scorched world closest to the Sun. Now let's move one step outward in the solar system, to Venus, our other neighbour, often called Earth's twin. At first glance, twin sounds friendly, like Venus should be almost the same as us, and in some ways it is. Venus is nearly the same size as Earth, just a little smaller, but don't let the nickname fool you. If Mercury felt harsh, Venus is something else entirely. Let's start with distance. On average, Venus is about 25 million miles away from Earth at its closest. That's around 40 million kilometers, which makes it the closest planet to us overall. If you compare that to Mercury, about 48 million miles, Venus can actually come almost twice as close. Imagine again that same airplane we talked about before, flying at 600 miles an hour. To reach Venus non-stop, it would take about 5 years. Still forever if you were stuck on a plane. But compared to Mercury's 9 years, Venus is practically in the neighbourhood. Now imagine looking up at the night sky and seeing Venus where the moon is. The difference would be stunning. Venus is almost the same size as Earth, so in our sky it would look enormous. The moon we know is about 2,000 miles across. Venus is over 7,000 miles across. That means in the sky, Venus would appear almost 4 times bigger than the moon. Instead of a small glowing disk, it would dominate the horizon, filling the night with a massive bright face. And brightness is the key word here. Even from where it really is now, millions of miles away, Venus is the brightest planet in our night sky. People call it the morning star or evening star because it shines so strongly. You can see it before sunrise or after sunset. If it were sitting right where our moon is, the glow would be overwhelming. Nights might not even feel dark anymore. Streets, forests, oceans, all of them would be lit up with a ghostly golden light, bright enough to cast shadows. You'd walk outside at midnight and still be able to see your own shadow stretching across the ground. The sight itself would be breathtaking, but there's something eerie about it too. The surface of Venus is hidden under thick clouds, so instead of seeing craters and detail like on the moon, you'd see a smooth glowing disk, almost too perfect. Like a giant lamp hung in the sky, too bright to ignore. Some people might find it beautiful, others might find it uncomfortable, as if the night had been stolen away. So, while Mercury would make our nights darker and harsher, Venus would do the opposite. It would flood the world with constant golden brightness. Peaceful at first, maybe even magical, but also strange, as if the boundary between day and night had been blurred. From a distance, Venus looks calm, smooth, almost elegant. But that's the trick of its thick clouds. Underneath them, the planet is one of the most hostile places in the entire solar system. Let's start with the heat. Venus is the hottest planet we know, even hotter than Mercury. And remember, Mercury is closer to the Sun. On the surface of Venus, the temperature stays around 900 degrees Fahrenheit, which is about 470 degrees Celsius. That's hotter than the inside of a pizza oven. Hot enough to melt metal. If you left a car parked there, it would sag into a puddle of metal and rubber in hours. Why so hot? It's because of Venus's atmosphere. It's made mostly of carbon dioxide, which traps heat like a giant blanket. On Earth, carbon dioxide is part of the greenhouse effect, which keeps our planet warm enough for life. But on Venus, the effect runs out of control. The atmosphere is so thick that standing on Venus would feel like being almost a mile under the ocean, with crushing pressure. That's why scientists call it a runaway greenhouse effect. It's not just warm, it's a permanent, deadly sauna. And then there are the clouds themselves. They aren't fluffy or harmless. They're made of sulfuric acid. Yes, acid, the kind that can burn through skin. Imagine endless storms of toxic clouds, thick enough to block almost all sunlight from reaching the ground. If you could stand on the surface and look up, the sky would be a yellowish haze, dark and suffocating. The sun would only be a dim glow, never shining directly. The winds on Venus are another nightmare. Up in the clouds, they whip around the planet at speeds of more than 200 miles per hour. That's faster than a hurricane on Earth, and it never stops. The entire atmosphere circles the planet in just a few days, while the solid planet itself turns painfully slowly. One full spin takes more than 200 Earth days. So while the ground crawls along in slow motion, the sky above it roars like a storm that never ends. If you put all of this together, the heat, the pressure, the acid clouds, the endless winds, Venus is less like Earth's twin and more like Earth's evil twin, a mirror that shows what can happen if a planet goes wrong. Now, imagine that kind of world hanging in our sky instead of the moon. Bright on the outside, hiding storms and fire beneath the clouds. To people looking up, it might feel both magical and haunting, a glowing reminder every night that even planets that look calm from far away can be the deadliest of all once you get close. If Venus ever took the place of our moon, the first thing we'd notice would be the light. Nights, as we know them, would almost disappear. Venus is incredibly bright, even from millions of miles away. It's the brightest object in the sky after the sun and moon. If it were orbiting at the moon's distance, the glow would be overwhelming. Every night would be like twilight, with the ground bathed in a golden, eerie light. Stars would fade from view, hidden by the glare. For humans who love stargazing, constellations might simply vanish from memory. This brightness would change more than just our view of the sky. Animals that depend on darkness, owls, bats, sea turtles, would be thrown into confusion. Many of them hunt, migrate, or lay eggs under the cover of night. With a glowing Venus overhead, those natural rhythms would collapse. Even humans, who already struggle with too much artificial light in cities, would find their sleep patterns disturbed. Imagine trying to fall asleep while a massive golden lamp hangs overhead every single night. Then comes the gravity. Venus is nearly the same size as Earth, much larger than the Moon. If it orbited as close as the Moon does now, its pull on Earth would be devastating. Tides wouldn't just rise a little higher, they could swallow entire coastlines. Twice a day, the sea could surge inland, drowning beaches, ports, and low-lying cities. Millions of people who live near the ocean would be forced to move. Our maps of the world's shorelines would have to be redrawn. And here's the important part. In reality, Venus is simply too big to ever be a moon. Its mass is about 80% of Earth's. That means the two wouldn't form a planet and satellite system at all. They'd orbit each other, like a pair of partners locked together. Astronomers call this a double planet system. Over time, their orbits would grow unstable, tugging at each other until chaos followed. And that chaos wouldn't just be a little wobble in the sky, it could turn into something far bigger. A slow drift toward each other, ending in the ultimate crash. Imagine Earth and Venus, two huge planets colliding after millions of years, a final impact no one could survive. But for the sake of this thought experiment, let's keep imagining Venus peacefully circling Earth, even if physics wouldn't allow it. Back to the picture, the climate. That's where it gets terrifying. Even though Venus's heat wouldn't transfer directly to Earth, its presence would still change our atmosphere. The sheer brightness would reflect extra sunlight onto Earth's surface, warming it more than usual. Combine that with stronger tides and shifting weather, and Earth's climate might tip toward instability. We could see hotter summers, stronger storms, and entire regions becoming harder to live in. But perhaps the biggest change would be psychological. The moon, soft and familiar, feels safe. Venus would feel alien. Looking up, we'd see not a calm friend in the sky, but a massive, glowing world that we know is deadly. A world where the air crushes, the clouds burn, and the ground melts metal. Every night, that reminder would hang above us, beautiful but unsettling. So, while Mercury, as our moon, would give us harsher tides and darker nights, Venus would rob us of darkness altogether. It would reshape our oceans, disturb our climate, and change how humanity feels about the night sky. The balance we rely on would vanish, leaving Earth lit by a world that looks like a star but hides an inferno beneath its clouds. We've seen Mercury, dark and scarred, and Venus, bright but deadly. Now let's move one more step outward, to a planet that gets a lot of attention: Mars. Unlike Mercury and Venus, Mars actually feels familiar to us. People dream about walking on it, living on it, even building whole cities there one day. But what if Mars wasn't out there, circling the sun? What if it were right above us, in place of the moon? First, the distance. On average, Mars sits about 140 million miles away from Earth. That's around 225 million kilometers, much farther than Mercury or Venus. If you could hop on that same imaginary airplane we used before, flying 600 miles an hour non-stop, it would take more than 25 years to reach Mars. 25 years, just sitting in a cramped seat, waiting to land. Compared to Venus, which we said would take about 5 years, Mars is way, way farther out. Now imagine that distance erased, and Mars pulled right up close, orbiting where the moon is. The first thing you'd notice is the colour. Instead of a pale white glow, the night sky would be ruled by a massive reddish sphere. Mars is often called the red planet, and for good reason. Its surface is covered with iron oxide, basically rust, which gives it that dusty red colour. From Earth we'd see a giant ball the colour of sunset, glowing faintly in the dark. And size matters here too. Mars is about 4,200 miles wide. That makes it more than twice the size of the moon, but still smaller than Earth. In our sky, it would look huge, bigger than Venus even, though not quite as blindingly bright. You'd see dark patches, bright deserts, and maybe even hints of its polar ice caps shining white at the edges. Mars wouldn't just be a spot in the sky, it would feel like a whole world hanging over us. There's another detail that would stand out. Mars has 2 tiny moons of its own, Phobos and Deimos. They're small potato-shaped rocks, not round like our moon. If Mars were in our sky, we might even catch glimpses of these little moons orbiting around it, faint dots moving across its red glow. Imagine looking up at night and not just seeing one new moon, but 3, Mars itself and its 2 strange little companions. For people on Earth, this view would be dramatic. A red planet dominating the horizon, with hints of ice deserts and tiny moons circling it. It would feel less like a calm night sky and more like living under the shadow of another world entirely. Beautiful, yes, but also a reminder that Mars is not just a neighbour planet. It's a frontier, a place both inviting and alien, always just out of reach, unless it were right above our heads. Mars may look calm from a distance, but if you ever stepped onto its surface, you'd realise how extreme it really is. This is a planet full of contrasts. Freezing cold, massive mountains, endless dust, and storms that can swallow the entire world. Let's start with the temperature. Mars is much colder than Earth. On average, it's about -80 degrees Fahrenheit, or -60 degrees Celsius. That's colder than Antarctica. During the day near the equator, it can warm up to something closer to a chilly winter on Earth, maybe 20 or 30 degrees Fahrenheit, just below freezing. But at night, the temperature plunges again, down to -100 or even -150. Imagine standing in a desert where the sun sets and suddenly the whole world becomes as cold as the poles. Then there's the atmosphere. Mars has air, but it's incredibly thin. If Earth's atmosphere is like a thick blanket, Mars's is like a single bedsheet. It's made mostly of carbon dioxide, with only a trace of oxygen, not nearly enough to breathe. And because the air is so thin, it doesn't hold heat. That's why Mars swings from kind of cold in the day to deadly cold at night. The thin atmosphere also means the sky on Mars isn't blue like ours. Instead, it's a dusty pink, tinted by iron particles floating in the air. But the most dramatic feature of Mars? It's storms. Mars has dust storms unlike anything on Earth. Sometimes they cover just a small area, but other times they grow so massive that they blanket the entire planet. Imagine looking through a telescope at Mars and seeing it vanish under a haze of dust for weeks at a time. If Mars replaced our moon, we might even see hints of those storms from Earth. Clouds of rust-coloured dust sweeping across its surface, shifting the patterns on that glowing red ball in the sky. And let's not forget the landmarks. Mars is home to Olympus Mons, the largest volcano in the solar system. It's about 3 times taller than Mount Everest, and as wide as the entire state of Arizona. Just think about that. A mountain so big it could cover an entire region of Earth. Mars also has Valles Marineris, a canyon system more than 2,500 miles long. That's about the distance from New York to Los Angeles. If you stood at the edge, you'd be looking into a crack that stretches across a whole continent. Finally, there's ice. At its poles, Mars has ice caps made of frozen water and carbon dioxide. They grow and shrink with the seasons, a reminder that even this cold, dry planet still has traces of something familiar. If you looked up and saw Mars as our moon, you might notice faint white patches at the top and bottom, little glimmers of ice shining from an otherwise rust-red world. So Mars isn't just the red planet, it's a world of storms, mountains, canyons and ice. A place where the ground tells stories of volcanoes, taller than any on Earth, and valleys deeper than anything we've ever walked through. If it hung above us every night, we'd be staring not just at another planet, but at a landscape of extremes. If Mars ever replaced our moon, the effect on Earth would be dramatic in both science and culture. First, the gravity. Mars is more than twice the size of our moon, so if it orbited as close as the moon does now, its pull on Earth's oceans would be much stronger. Tides would rise far higher, flooding coastlines day after day. Cities by the sea, places like Miami, Shanghai, or Amsterdam, would have to fight floods constantly, or be abandoned altogether. The moon already shapes our tides, but with Mars, the rhythm of the oceans would become violent, unstable. Then there's the light. Mars isn't bright like Venus, but its red glow would colour the night sky. Instead of gentle silver light, we'd live under nights, tinted in rust and copper. For animals and people, that shift might change how we feel about nighttime. Darkness would no longer feel clean or calm. It would be painted with the shadow of a planet that looks alien, dry, and cold. Our own moon is tiny compared to Earth, only about 1/80th of its mass. That's why Earth can hold it steady. But Mars, or Venus, they're way heavier. Mars is about 1/10 the mass of Earth, which sounds small, but in cosmic terms it's heavy enough to upset the balance. And Venus almost the same size as us. If one of them circled this close, it wouldn't really be a simple planet and moon anymore. Instead, the two would pull on each other, like dance partners locked together. Astronomers call this a double planet system. And just like we said with Venus, that kind of system doesn't stay calm forever. Over millions of years, the orbits could drift, tugging closer and closer until the two worlds risked colliding. The difference is speed. Venus, being almost Earth's twin, would pull harder, and chaos might come sooner. Mars, being smaller, might take longer, but the ending would be the same. Imagine Earth and Mars, after eons of slow movement, finally crashing together, a violent ending that would erase both worlds. But for tonight, let's keep that possibility in the background, and just imagine Mars peacefully circling us, like a giant red lantern in the sky. People already feel a strange connection to Mars. For centuries, it's been a symbol of war, a fiery red point in the sky. Today, it's become something different, a dream. Scientists believe that long ago, Mars may have had oceans and rivers. Evidence shows valleys carved by water and minerals that form only in liquid water. In other words, Mars might once have looked a little like Earth, blue skies, seas, maybe even conditions for life. That's why so many people imagine bringing Mars back to life. There's even a word for it, terraforming. The idea is to slowly change Mars's air and temperature so humans could one day live there without spacesuits. It sounds like science fiction, but some scientists take it seriously. And one of the loudest voices behind this dream is Elon Musk. He's a billionaire and the founder of SpaceX, a company that builds rockets. His vision is to make humanity multiplanetary. In other words, to have people living not just on Earth, but on Mars too. He talks about sending the first colonists there within our lifetime. Now imagine Mars hanging right above us every night, close enough to feel its pull. Instead of just being a dot in the distance, it would dominate the sky, a reminder of both its past oceans and its possible future as humanity's second home. Teenagers, kids, adults, everyone would look up and feel it calling. The idea of Mars would stop being distant science fiction. It would feel personal, real, something we could almost reach out and touch. Of course, along with that inspiration would come chaos on Earth. Higher tides, ruined cities, disrupted ecosystems. Mars as our moon would reshape the physical world in dangerous ways. But it would also reshape our imagination. It would be both a threat and a dream, a planet that reminds us how fragile Earth is and how much we long for new horizons. We've seen Mercury, Venus, and Mars, each one bigger than the moon, each one making Earth less stable. And maybe those were still easy to picture, Mercury as a supermoon, and Venus and Mars acting like pushy neighbours. But now we've reached Jupiter, and this is the part where imagination turns into pure science fiction. First, the distance. On average, Jupiter is about 484 million miles from Earth. That's around 778 million kilometres. Just hearing that number feels impossible. If you tried our imaginary airplane again, cruising at 600 miles an hour, it would take more than 90 years of flying non-stop to reach it. You could board the plane as a teenager, live your whole life on board, and still never see Jupiter out the window. That's how far it really is. Now bring it closer. Imagine erasing those hundreds of millions of miles and pulling Jupiter right up to where our moon is now, only about 238,000 miles away. That's about 384,000 kilometres. The sight alone would be unlike anything we've ever known. Jupiter is over 86,000 miles wide, more than 11 times wider than Earth. In our sky, it wouldn't just look big, it would take up almost everything. Look up, and you wouldn't see stars anymore, just endless bands of orange, white and red swirling across the heavens. And then there's the storm, the Great Red Spot, a hurricane so massive it could swallow Earth whole. On our planet, storms last a few days, maybe a week. This one, it's been raging for at least 300 years. Astronomers first spotted it in the 1600s, and it's still there. Imagine walking outside at night, looking up, and seeing that storm staring down at you like a giant, unblinking eye. Beautiful, but terrifying. Here's where things flip. Jupiter is so massive that this experiment doesn't even work in real physics. It's more than 300 times heavier than Earth. If it ever got this close, Earth wouldn't be the main planet anymore. Jupiter would keep Earth as its moon. We'd be the satellite, circling this giant, not the other way around. It flips the whole idea upside down. That's what makes Jupiter so fascinating and terrifying. We can still imagine it for fun, but the truth is, no planet this big could ever orbit Earth. The gravity would tear everything apart. Still, picture it for a moment. Walking outside at night, and instead of a small glowing moon, the entire sky is taken up by Jupiter. Stripes of clouds, storms that rage for centuries, colours shifting like an oil painting in motion. It would be both the most beautiful and the most terrifying view humanity has ever known. The real nightmare starts when you think about what Jupiter's atmosphere and radiation would actually do to Earth. So far, we've only talked about what Jupiter would look like in the sky. But if Jupiter really sat where our moon is, it wouldn't just be about the view. It would change everything around us. First, the atmosphere. Jupiter isn't a solid planet like Earth. It's a gas giant. Basically, a world made almost entirely of hydrogen and helium. That means there's no ground, no solid surface you could stand on. If you tried, you'd just sink deeper and deeper into endless clouds until the pressure crushed you. From far away it looks soft, like painted swirls. Up close, it's lethal. Then there's the radiation. Jupiter has an incredibly strong magnetic field, about 20 times stronger than Earth's. That magnetic field traps charged particles from the Sun, turning the space around Jupiter into one of the most dangerous radiation zones in the entire solar system. If Jupiter were right above us, those particles would bombard Earth constantly. Life as we know it, humans, animals, even plants, wouldn't survive long under that invisible storm. It would be like living inside a giant microwave. And we can't forget its moons. Jupiter has at least 79 of them, with 4 big ones that astronomers call the Galilean moons. Io, Europa, Ganymede, and Callisto. Each one is fascinating on its own. Io is covered in volcanoes that erupt sulfur high into space. Europa has a frozen surface that might hide an ocean of liquid water beneath. Ganymede is so big, it's larger than Mercury. If Jupiter were this close, all those moons would be pulled in too, lighting up the night sky with dozens of glowing orbs. It would look beautiful at first, like a cosmic light show, but the gravitational chaos would be unbelievable. Their orbits would clash with Earth's pull, creating a dance of collisions and destruction in the long run. So imagine it, Earth under a striped sky, blasted by invisible radiation, while dozens of moons wheel around above our heads. It wouldn't just be Jupiter as a moon. It would be like Earth trapped inside Jupiter's kingdom, a world we could never escape from. So what would actually happen to Earth if Jupiter were hanging above us like the moon? The short answer, disaster on every level. But let's take it step by step. First, the tides. Remember how Mercury or Venus already pushed our oceans too far? Multiply that by 100. Jupiter's gravity would yank on Earth's oceans so hard that tides wouldn't just wash over beaches, they'd surge inland for miles. Entire coastlines would be underwater twice a day. Cities like New York, London, Shanghai and Rio would be swallowed. Our maps of the world would stop making sense because every shoreline would constantly shift. Millions, maybe billions of people would have to abandon their homes. But it's not only the oceans, Earth itself would feel the pull. Jupiter's gravity could trigger earthquakes and volcanic eruptions as the planet's crust strained under the stress. Imagine skyscrapers swaying, highways cracking, and whole regions sinking as the ground buckled. Life on land would be shaken apart, not just drowned. And then there's the orbit. Earth right now moves around the Sun in a stable path, guided by a careful balance of forces. Put Jupiter this close, and that balance collapses. Instead of circling the Sun peacefully, Earth might be pulled into a wild new orbit, stretched, tilted, or even ejected from the solar system entirely. Picture Earth flung out into deep space, frozen in eternal darkness, just because Jupiter moved in too close. And if that wasn't enough, don't forget the double planet problem. A giant like Jupiter can't just be a moon. It's too heavy. Over time, Earth and Jupiter would lock together in a tug of war. And in the slowest, most terrifying dance in the universe, the two worlds might drift toward each other until collision became unavoidable. It wouldn't happen overnight. It could take millions of years, but the ending would be the same. Earth torn apart, swallowed by a planet more than 300 times its mass. It sounds like science fiction, and in a way, it is. But the physics behind it are real, and that's why Jupiter as our moon is more of a nightmare than a dream. So far, every planet we've imagined as a replacement moon has brought more danger than comfort. But we're not done yet, because next comes Saturn, another giant, almost as big as Jupiter, but with something that makes it even more striking. Those famous rings, the most famous feature in the entire solar system. Let's start with distance. On average, Saturn sits about 883 million miles from Earth. That's more than 1.4 billion kilometers. Numbers that huge almost lose meaning. So let's use our imaginary airplane again. Cruising at 600 miles an hour, non-stop, it would take you more than 160 years to get there. That's almost twice as long as the trip to Jupiter. You'd need not one lifetime, but two, just to reach the gate. And then, imagine erasing that distance, bringing Saturn all the way in, right to the spot where our moon is now. Suddenly, the most distant-looking planet becomes the closest neighbour in the sky. The sight would be unreal. Saturn itself is huge, more than 72,000 miles across, about 9 times wider than Earth. That alone would dominate the heavens. But the real show, the rings. They're made mostly of ice and rock, tiny particles and massive chunks, circling the planet in glowing bands. If you stood outside at night and looked up, those rings would stretch across the horizon like a giant halo. They wouldn't be a faint arc. They'd blaze in the sky, reflecting sunlight, lighting up the night brighter than any full moon. And here's a fact that might surprise you. The rings are thin. For all their size, they're only about 30 feet thick in most places, thinner than a house is tall. Imagine something spread out hundreds of thousands of miles wide, but barely thicker than your living room ceiling. That's Saturn's rings. From Earth, if Saturn replaced the moon, the view would be breathtaking, but also eerie. We'd see stripes of light splitting the night sky, stretching from horizon to horizon, never fading. Stars would vanish behind them. Constellations would break apart. It would look like the sky itself had been carved into pieces. Compared to Jupiter, Saturn feels gentler, almost elegant, with its shimmering crown of ice. But don't let that beauty fool you. A planet this big, this heavy, this close. The consequences would be just as dangerous. Start with gravity. Saturn is the second largest planet in our solar system, more than 90 times heavier than Earth. That weight would pull on us with a force far beyond anything our planet could handle. Just like with the other planets we've imagined before, the tides would rise far beyond anything we know. But this time, it would be on a whole new scale. Imagine entire oceans rising and falling not by feet, but by hundreds of feet. Whole coastlines would be erased, and the sea could swallow cities thousands of miles inland. The daily rhythm of waves would turn into a global flood cycle, and it wouldn't stop with the oceans. Saturn's pull would tug on Earth's crust itself. Just like with Jupiter, the stress could unleash earthquakes and volcanic eruptions across the planet. Buildings wouldn't just shake, entire mountain ranges could shift, volcanoes could erupt one after another, and the ground beneath our feet would feel alive, restless, impossible to trust. Now let's think about the rings. At first glance, they seem harmless, just bits of ice and rock circling Saturn. But if the whole system were this close, the rings themselves would shine so brightly that they'd change Earth's nights forever. Imagine never having true darkness again. The rings would reflect sunlight like giant mirrors, glowing overhead and turning every night into a strange twilight. Owls, bats, and sea turtles would lose the darkness they depend on. Even humans already struggling with light pollution from cities would have their natural rhythms disrupted. Falling asleep under Saturn's rings would feel beautiful, but unnatural, like trying to sleep in a room where the lights never really go out. And here's another problem. Rings aren't stable. Over time, Saturn's rings are slowly falling apart, with pieces drifting toward the planet. If they were right above us, Earth's gravity could scatter chunks of ice and rock toward our atmosphere. At first, it might look like glowing meteor showers, streaks of light racing across the sky. But larger fragments could slam into the surface, creating craters, wildfires, and chaos. The rings that look so peaceful from afar could rain destruction down on us. Think back to what we said about Venus and Mars, how planets that are too heavy can't really act as moons. Saturn is far beyond that. It's over 90 times the mass of Earth. Put it this close, and the system would become unstable almost immediately. Instead of Earth holding Saturn in place, the two would pull on each other. Earth's orbit around the Sun would twist and shift, thrown off balance by Saturn's enormous gravity. Seasons could stretch or vanish. The planet could tilt into new angles, and the rhythm of life would collapse. And then comes the long-term picture. Just as with Jupiter, Earth wouldn't really be the main planet anymore. Saturn would be the master, and Earth would fall into the role of its satellite. For a while, the system might look stable, Earth circling Saturn while both still orbit the Sun. But over millions of years, those orbits would drift, slowly, quietly, almost unnoticeably. The two worlds could begin to spiral toward each other. Imagine that ending. Not a sudden crash, but a slow pull over eons until one day Earth finally falls into Saturn. Our world erased in a collision with a planet almost 100 times heavier. The rings we once admired in the sky would be the last thing we'd ever see. In the short term, Saturn would flood our oceans, shake our ground, and light our nights with endless twilight. In the long term, it would pull us into chaos until nothing of Earth remained. Compared to Jupiter, Saturn might feel more elegant, more beautiful, but the truth is their stories are nearly the same. Giants don't make good neighbours, and Saturn proves that just as much as Jupiter does. So let's step away from the giant worlds for a moment. Next comes Uranus, smaller than Jupiter and Saturn, tilted on its side, and carrying mysteries of its own. Don't get me wrong, it's still massive, 4 times wider than Earth and about 14 times heavier. But compared to the giants, it feels almost modest until you hear its story. Because Uranus isn't just another icy planet, it's the planet that lies on its side. What does that even mean? Well, every planet spins on an axis, an invisible line that runs from the North Pole to the South Pole. Earth's axis is tilted a little, about 23 degrees. That's why we have seasons: summer, winter, spring, fall. But Uranus, its axis is tilted about 98 degrees. That's not a tilt, that's a topple. Imagine taking a spinning globe and knocking it flat on its side. That's Uranus. What does this do? It makes Uranus's seasons completely bizarre. Each pole spends about 42 years in constant daylight, then 42 years in constant darkness. Imagine living in the Arctic on Earth, where you might see months of sun or night, but stretch that out to decades. Entire human lifetimes lived in endless day, followed by endless night. And now, let's bring back our favourite test: distance. On average, Uranus is about 1.8 billion miles from Earth. That's nearly 2.9 billion kilometres. The numbers keep getting bigger and harder to imagine. So yes, it's time to call on our favourite imaginary airplane again. At 600 miles an hour, non-stop, the trip would take about 3,500 years. That's not just you grow old on the plane, that's entire civilizations rise and fall while you're still stuck in coach. Compared to this, the 90 years to Jupiter felt like a weekend trip. But erase that distance. Pull Uranus all the way in to the spot of our moon, 238,000 miles away. The view would be striking. Uranus has a pale blue-green colour thanks to methane in its atmosphere. It looks calm, almost like a giant marble hanging in space. But knowing it's tipped on its side makes the image strange, unsettling. We'd see it roll across the sky differently than any other planet. Its equator would be tilted toward us, its poles aiming where no poles should. It would be a reminder every night that not all planets play by the same rules. From far away, Uranus looks calm, but that calmness is a trick. First, Uranus is what astronomers call an ice giant. Not because it's literally made of ice cubes floating around, but because much of it is made of icy materials like water, ammonia, and methane. Beneath its atmosphere, there's no solid ground, just layers of dense fluids under crushing pressure. If you try to land, you wouldn't find a surface. You'd sink into cold, dark layers until the pressure and temperature destroyed you. And while the planet looks smooth, its atmosphere is anything but calm. Uranus has some of the fastest winds in the solar system, reaching up to 500 miles an hour, about as fast as a jet plane. Imagine an entire planet wrapped in winds strong enough to tear through anything. If Uranus replaced our moon, those winds wouldn't reach Earth directly, but the sight of that spinning sideways world would be a reminder that even the quietest-looking planets can hide chaos inside. Now let's talk about the rings. Saturn is famous for its huge glowing rings. Uranus has rings too, but they're different. They're thin, dark and hard to see, almost like faint scratches in the sky. There are 13 of them, made of tiny bits of rock and dust. If Uranus were in the moon's place, we'd see those rings glowing faintly in the sunlight, stretching around the blue-green planet like shadows drawn across the heavens. Not bright, not showy like Saturn, but eerie, subtle, almost ghost-like. And Uranus has moons too, at least 27 of them. The biggest ones have names from Shakespeare: Titania, Oberon, Ariel, Umbriel, and Miranda. Each one is unique. Miranda, for example, looks like a patchwork world, with cliffs taller than Mount Everest and landscapes that seem torn apart and stitched back together. If Uranus hovered close to Earth, those moons would join the show in our sky, tiny lights circling the tilted giant. They'd look beautiful, but their gravity added to Uranus's would only make Earth's own stability more fragile. So Uranus, for all its calm appearance, is really a world of hidden extremes: icy layers, supersonic winds, ghostly rings, and moons with alien landscapes. Seen from Earth's surface, it would be mesmerizing, but also unsettling. So what if Uranus really took the place of our moon? At first, it might seem less frightening than Jupiter or Saturn. After all, Uranus is smaller, only about 14 times the mass of Earth, not 90 or 300 times like the giants. That difference does matter. Earth wouldn't instantly become Uranus's sidekick like it would with Jupiter. The balance might last longer, but don't let that fool you. The results would still be devastating. Let's start with the tides. Compared to our moon, Uranus's gravity would be overwhelming. Oceans would surge far beyond their usual limits. Not as extreme as Saturn's floods, but still enough to erase cities, farmlands, and entire regions near the water. Imagine the Atlantic pushing deep into New York or Florida twice a day, or the Pacific swallowing California's coasts. Billions of people around the world depend on stable shorelines. All of that would vanish. Next comes Earth's crust. Uranus's pull could twist and strain the planet itself, waking up fault lines and volcanoes. Whole regions might become unlivable as quakes shattered cities and ash-darkened skies. Compared to Saturn, the stress would be lighter, but even lighter here means catastrophic. It would feel like Earth itself had developed a restless heartbeat. And don't forget the tilt. Uranus doesn't just orbit, it rolls on its side. If it circled Earth this way, its gravity and sideways spin could nudge Earth's own tilt out of balance. Right now, our tilt is gentle, 23 degrees, and it gives us seasons. Even a small change could throw the rhythm of climate into chaos. Winter's colder, summer's hotter, storms stronger. If Uranus pulled us into a wobble, we might face decades of unstable weather, or even permanent shifts that no generation could adapt to. Finally, the long-term problem: double planet dynamics. Just like with Venus and Mars, Uranus is too massive to act as a simple moon forever. Over millions of years, the balance could break down. Earth and Uranus might drift closer, pulled by each other's gravity, until collision became unavoidable. Not tomorrow, not even in our lifetime, but someday, inevitable. So Uranus would give us floods, quakes, and unstable seasons in the short term, and doom in the long term. Smaller than the giants, yes, but no safer. It proves a pattern we've seen again and again. Planets bigger than our moon don't just light up the night sky, they tear Earth apart. And yet, our journey isn't finished, because beyond Uranus lies Neptune, the farthest of the big planets, deep blue, stormy, and mysterious. If Uranus is the tilted giant, Neptune is the distant king of winds. We've made it all the way from Mercury to Uranus, each planet bigger, stranger, more dangerous than the moon we know. And now we've reached the edge, Neptune, the last of the big planets, orbiting farthest from the Sun. Let's start with distance. On average, Neptune is about 2.7 billion miles from Earth. That's more than 4.3 billion kilometers. Numbers that big almost stop meaning anything. So yes, it's time to bring back our favorite test. Imagine hopping on our trusty imaginary airplane again, cruising at 600 miles an hour. To get to Neptune? The trip would take over 5,000 years. 5,000 years. That's longer than all of recorded human history. Imagine people boarding in ancient Egypt and their descendants still flying today, still eating peanuts in coach. Now bring Neptune close, all the way down from billions of miles to just 238,000 miles away. The real distance to the moon. The sight would be breathtaking. Neptune is about 30,000 miles across, almost 4 times wider than Earth. In the night sky, it wouldn't fill everything like Jupiter, but it would still dominate the heavens, glowing in a deep, rich blue. That colour comes from methane in its atmosphere, which absorbs red light and reflects blue. No other planet looks quite like it. Neptune is like a sapphire jewel hanging in the dark, but don't let the calm look fool you. Neptune has the fastest winds in the entire solar system, over 1,200 miles per hour, faster than the speed of sound. That's like Earth's strongest hurricanes multiplied by 10. If you could stand on Neptune, which you can't because there's no solid ground, the storms would rip across the horizon faster than you could turn your head. From Earth's surface, looking up at Neptune as our moon, you'd be staring at a planet wrapped in endless gales, storms circling at supersonic speeds. Beautiful, but terrifying. A silent chaos painted blue. Compared to Uranus, Neptune feels like its darker twin. Similar in size, both icy giants, but Neptune is more intense, more violent. Where Uranus lies quietly on its side, Neptune is always raging, always restless. The most famous was spotted in 1989 by the Voyager 2 spacecraft, the Great Dark Spot. Think of it as Neptune's version of Jupiter's Great Red Spot. Only instead of a rusty red colour, it was an inky hole in the clouds, a storm bigger than Earth itself. And here's the strange part. It didn't stay. Unlike Jupiter's storm, which has raged for centuries, Neptune's storms appear and disappear. They pop up, grow huge, and then vanish in just a few years. Imagine a hurricane the size of Earth, forming and fading before you even finish high school. That's Neptune. And here's the mystery. Neptune is the farthest planet from the Sun, almost 30 times farther than Earth. Sunlight there is 1,000 times weaker than what we feel here. So you'd expect it to be quiet, cold, almost frozen. But Neptune is alive with energy. Its winds are the fastest in the solar system, over 1,200 miles per hour, faster than the speed of sound. Where does all that energy come from? Scientists think Neptune generates its own heat deep inside, radiating more energy than it gets from the Sun. It's like a planet with a hidden furnace powering endless storms in the darkness. If Neptune replaced our moon, this chaos would be on full display. Look up at night, and instead of a pale, steady circle, you'd see storms swirling across a glowing blue giant. One year there might be a huge dark spot, a hurricane wider than Earth. A few years later, it might vanish, replaced by new storms on the other side. The sky would always be changing, never calm, never predictable. Compared to Uranus, which looks almost plain and featureless, Neptune is dramatic. It's the showman of the icy giants, restless and stormy, even at the edge of the solar system, where the sun barely shines. And if it ever orbited Earth, our nights would be lit, not by peace, but by constant reminders of chaos. So what would actually happen if Neptune sat where our moon is now? It's smaller, right? Only about 17 times the mass of Earth. Not 90 or 300. But smaller in this case doesn't mean safe. The pattern we've seen with Venus, Mars, Jupiter, Saturn, and Uranus still holds. Anything this big, this close, tears Earth apart. Start with the tides. Neptune's pull would be weaker than Saturn's, but still far beyond anything Earth could survive. Coastlines wouldn't just shift, they'd drown. Twice a day, walls of water could roll inland, swallowing ports, farmland, and entire cities. Think of the floods we imagined with Uranus, only pushed even harder. Then the crust. Just as with Saturn, the pull wouldn't stop at the water. Earth itself would bend and strain. Fault lines would snap, volcanoes would erupt, mountain ranges could crumble under the stress. Remember how we said with Uranus it would feel like Earth developed a restless heartbeat? With Neptune, that heartbeat would be stronger, pounding, irregular, destructive. And the tilt. Neptune wouldn't just pull on Earth's surface, its sideways spin could nudge Earth's own tilt. We already know how fragile our seasons are. A few degrees off, and life as we know it changes forever. Imagine winters so long and brutal they froze continents, or summers so intense that crops withered. Compared to the gentle 23-degree tilt that makes Earth livable, Neptune's influence could drive us into chaos, and long-term, the same slow dance we saw with the other giants. Neptune might not overpower Earth instantly like Jupiter, but given millions of years, the result would rhyme. Earth and Neptune locked together, drifting closer until the pull became impossible to resist. Two worlds spiraling into a collision. A smaller giant, yes, but the same final act. Destruction. So Neptune, the most distant planet, would bring destruction as surely as the rest. We've replaced the moon with every planet, from Mercury to Neptune. Each one changed Earth, sometimes in small ways, sometimes in catastrophic ones. And now it's time to look at the bigger picture and ask, what does this tell us about our own moon? The one we're lucky enough to have. The moon feels different now, doesn't it? It isn't the biggest, it isn't the brightest, it doesn't have storms that rage for centuries, or rings that stretch across the sky. But maybe that's exactly the point. The moon is simple, calm, balanced, just enough gravity to shape our tides, but not enough to drown our cities. Just enough light to guide us in the dark, but not enough to erase the stars. It gives us rhythm, stability, and comfort, things no other planet could ever offer. So maybe that's what tonight's journey really shows us. Not how terrifying the other planets could be, but how lucky we are to have exactly the moon we do. A soft light in the night sky, a gentle partner for Earth. Not too much, not too little, just right. If you found this sleepy science journey in Roblox-style relaxing, you might consider liking the video and subscribing. No pressure, just if it feels right. For now, the most important thing is that you can rest, knowing that our real moon is right where it belongs. So close your eyes, let the noise of the day drift away. Good night.